A beginner's guide to calculating annual effective interest rates. Learning objectives. To define APR and gain an in-depth knowledge of its importance in microfinance. Understand how to calculate APR under several different scenarios. To investigate personal discount rates and how they may affect the APR that borrowers are willing to accept. What is the annual percentage rate, or APR? APR is the rate of interest charged per payment period on a loan times the number of payment periods in a year. Effective APR is the sum of fees and compounded interest across a year on a loan. Effective APR is a more true measure of interest and is more useful when comparing loans of different terms and conditions. Why is this particularly important in microfinance? Although progress is being made, microfinance is currently a low transparency industry. Coupled with generally weak and differing political and regulatory environments, clients have little information on interest rates outside of their locality. Microfinance clients on average lack a formal education and are not aware of the sensitivity of effective interest rates due to change in loan terms and conditions. It will be shown that bribes or fees, which are still existing in microfinance, can increase effective interest rates while leaving the stated interest rate unchanged. The demand for microfinance has been found to be relatively inelastic, and thus microfinance institutions have a lot of freedom when playing with interest rates. The only risk on the supply side is charging an interest rate so high that it pushes the best credit risk out of the market.
In this slide, you will see formulas that can help you in calculating annual effective interest rates. In this formula, PMT represents payment. Present value is represented by PV. The nominal interest rate is represented by I, and the interest period is represented by N. In this next formula, effective interest rate is represented by IE. Payments over principal, interest plus fees, is represented by POP. Average outstanding principal is represented by AOP, periods in a year by K, and periods in the loan term by T. In this final formula, annual effective interest rate is again represented by IE, and nominal interest rate is represented by I. Finally, nominal interest rate periods in a year is represented by N. Let us start with a simple loan with an end-of-term lump sum payment. In this example, the loan amount is $500 to be repaid in 6 months with an interest rate of 30%. In a case of a simple loan with no compounded interest and a lump sum payment, the effective interest rate equals the annual interest rate, as shown by this example. Now, let us consider the same situation, except with the interest compounded once. In this example, following calculations, you find that the effective interest rate has more than doubled. Now, let us consult a slightly more complex situation. In this example, the loan amount is $360. The term is 9 monthly payments, and the annual interest rate is 30%, with a flat interest paid on the loan amount. According to the calculations in the table presented below, you will find that in this instance, the effective interest rate is 54% per year. Now let us consider the same loan, but with all the interest paid up front. Although still with an interest rate of 30%, with this simple trick of putting the interest all up front, you have changed your effective annual interest rate to over 6 times as much, to nearly 200%. Now let us consider interest paid on the declining principal. According to the calculations in the chart below, in this situation, the stated interest rate is actually equal to the annual effective interest rate. Now let's consider paying up front all of the interest on a declining balance. According to these calculations, the annual effective interest rate is slightly over 40% per year. However, this is a staggering difference when compared to the interest paid up front on a flat rate interest loan, which was near 200%. Let's consider one final example. In this example, there is a loan with interest charged on a declining principal with a service fee of 5% paid upon loan dispersal. This results in an interest rate of nearly 53% per year. Notice from these calculations how the interest rate has once again increased by a considerable percentage.
What interest rate should a microfinance institution charge? All around the world, MFIs are charging interest usually of at least 20%. These high interest rates are alarming to certain people and draw criticism for being unethical. But where do these rates come from? The Consultative Group to Assist the Poor, or CGAP, has come up with a formula of effective interest rates that MFIs should follow. How do personal discount rates relate to APR? Here's the formula for receiving a sum in the future. How do personal discount rates relate to APR? Here's one scenario. Informal moneylender offers $20 now, and an MFI offers $200 in 2 weeks. APR is significantly higher on the $20. However, borrower may have such a high personal discount rate that the present value of the $200 with lower APR is worth less than the $20 with a higher APR. Thus, the quantitative goal of microfinance should be to help lower the discount rate of individuals. So, what should be taken away from this? 1. Interest rates fluctuate significantly based on simple changes in loan terms. Calculations for finding effective interest rates are not simple. There is a need for a consistent standard to avoid such problems, and higher personal discount rates cause many to take poor loan terms. Questions to be asked. What loan terms are ideal for MFI clients? Can this information be of use to MFI clients? How can improvements be made in the industry, and what specific policies can be used to lower personal discount rates?